Welcome to all of you. Now we discuss about Unit-3 2021 Biomathematics Semester 5 CBCS Mathematics Honors University of Calcutta. Question paper 2021 Unit 3 Question 8a. Suppose x star is a fixed point of the system xn plus 1 equal to f of xn, where fx is a continuously differentiable function and modulus of f dash x star not equal to 1. Prove that x star is asymptotically stable if modulus of f dash x star is less than 1 and unstable if modulus of f dash x star is greater than 1. And this answer already given in 2023 Unit 3 question 8a. So this is repeated. Please see this question paper answer 2023. Question 8b. Consider the following nonlinear difference equation xn plus 1 equal to lambda xn whole divided by mu plus xn, where lambda greater than 0, mu greater than 0. Find the fixed points and discuss their stability. We have the system is this, for fixed point x star, this xn plus 1 equal to xn equal to x star, and actually this is the fixed point, not points. So we put x star in place of xn plus 1 and xn in 1. We get this equation x star common, lambda by mu plus x star minus 1 equal to 0. So x1 star equal to 0 and x2 star equal to lambda minus mu. So there are two fixed points, x1 star and x2 star. And for feasibility of x2 star, lambda minus mu greater than 0. That is, lambda is greater than mu. Let xn plus 1 equal to fxn, where fx equal to lambda x by mu plus x. Then f dash x equals to this mu lambda divided by mu plus x whole square. So f dash x1 star, that is f dash 0, equal to lambda by mu. So x1 star equal to 0 is locally asymptotically stable fixed point if modulus of f dash x1 star is less than 1, that is if lambda by mu less than 1, because lambda and mu both are positive, that is if lambda is less than mu. Note that in this case x2 star does not exist, because for existence of x2 star this greater than 0, so lambda greater than mu. So in this case, when x1 star is locally asymptotically stable, then x2 star does not exist. Next, f dash at the point x2 star this is equal to mu by lambda, and for feasibility already we have seen that lambda minus mu greater than 0, so lambda greater than mu. So x2 star equal to lambda minus mu is locally asymptotically stable if modulus of f dash x2 star is less than 1, that is mu by lambda. This mu by lambda f dash x2 star is less than 1, that is mu less than lambda. Mu less than lambda, already we have find this condition for feasibility of x2 star, for existence of x2 star. So when x2 star exists, then it is locally asymptotically stable. You can find, alternatively you can find by co-op diagrams for this stability analysis. This is the diagonal xn equal to xn plus 1, and this is a production curve fxn equal to lambda xn by mu plus xn. When lambda is less than mu, this horizontal axis is xn axis, this vertical axis is xn plus 1 axis, and this diagonal and the production curve intersects at this point origin when lambda less than mu. So only one equilibrium point and if we choose this x0 here, then by covariate diagram from these two reproduction curve to diagonals to reproduction curve, this corresponding point x1, next solution, and next to diagonals next to reproduction curve corresponding point is x2, next solution. And so this solution set approach to this x2 x star, this steady state, so x star equal to 0 is locally asymptotically stable here. And in this figure, when lambda is greater than mu, reproduction curve is this, and this diagonal is this, and if we choose so intersecting points with the diagonals on the reproduction curve, these two, and corresponding x coordinate, that is x1 star equal to 0 and corresponding x2 star is this. So there are two steady states when lambda is greater than mu. If we choose x0 is here initial solution, so from x0 to reproduction curve, then to diagonal line, and then to reproduction curve and corresponding this solution x1, and then to diagonals corresponding point is x2, next solution, and so on. And so here the solutions x0, x1, x2 approach this x2 star. So x2 star is locally asymptotically stable, and x1 star, that is equal to 0, is unstable. Next question. Question 9a, solve the following non-homogeneous system and discuss the stability of the fixed point by using cobweb diagram xn plus 1 equal to 3 by 4 xn plus 10. Given system is this, equilibrium point x star, so we write xn plus 1 equal to xn equal to x star and put all this in 1, we get x star equal to 40. So x star equal to 40 is the only equilibrium point of the system 1. Now stability analysis of this equilibrium point by cobweb diagram, let y equal to xn plus 1 and x equal to xn. So the given system becomes this y equal to 3 by 4x plus 10, and this is the reproduction curve. So and these corresponding diagonals, this y equal to x, xn plus 1 equal to xn. So this is the x-axis, that is xn, this is the y-axis, this is the xn plus 1, and this is y equal to x, this is the xn plus 1 equal to xn, and this is reproduction curve y equal to 3 by 4 x plus 10, actually xn plus 1 equal to 3 by 4 xn plus 10, and the intersecting points with the diagonals, this point, so corresponding x coordinate is the only steady state. And by this cobweb diagram, if we choose x0 less than 40, then cobweb diagram x0 to x1 to x2 and so on approach to x star from the left side, and from the right side if we choose x0 greater than 40, from this x0 to this next x1 to this to x2, and also from the right side the solution x0, x1, x2 approach to x star equal to 40. So x star equal to 40, this steady state is locally asymptotically stable by cobweb diagram. And question B, consider the discrete time period or prey system xn plus 1 equal to a xn bracket 1 minus xn minus b xn yn plus 1 equal to minus c yn plus d xn yn, where a, b, c, d are positive parameters. Find the fixed points of the system and discuss the stability. Actually, already we have answered the question in 2023 Unit 3 question 9a. Please see this video. Thank you. This completes the Unit 3 2021 Biomathematics.